Hi class, today we're going to look at section 1.2, functions given by tables. Objective, to understand functions given by tables. Reading tables of values. Function can be used in the form of tables of values. Function given in tables may always leave gaps and are incomplete. Tables often show trends that are not easily determined from formulas. So you can see that tables have their advantages and disadvantages. Let's look at example 1. The population N of the United States depends on the date D. So we know that N depends on D, so N is the dependent variable and D is the independent variables. Here, written in function notation, N of D here. So the table below shows the population in million each decade from 1970 to 2010. From this table, I can easily find out the population in 1980. The population in 1980 is 226.54 million. So I have a question here. I must answer it in a complete sentence. So I write my sentence here. The population in 1980 was 226.54 million. What does N of 1970 equal 203.3 means? In this course, you would have to also tell what things mean. So N represents the population, 1970 is the year, and 203.3 means 203.3 million. Putting it all together, we say that N of 1970 means that in 1970, the population in the US was 203.3 million. And you have to write the word millions down. Now, in example 2, we see that we want to find a population in 1975. Since 1975 is right smack in the middle between 1970 and 1980, we can use the average to figure this out. This is one method of estimating the value for 1975. To find an average, you add the two numbers and divide by 2. So we're going to add up the population in 1970, the population in 1980, and divide it by 2. And don't forget to put the parentheses in the numerator. And you get 214.92 million people. What if the number is not smack middle? How would you find the value? You can estimate this value by the average rate of change. The average rate of change is estimated by the change in the value divided by the change in time. Okay. So we want to find the estimated population for 1972. So in order to do that, we must find the average rate of change between 1970 and 1980, because 1972 is right in the middle. It's 2 years from 1970. So if we know the value for 1970, we can add the difference to that value to get 1972. So how are we going to do this? The average rate of change is equal to the difference in the value of 1980, the population 1980 minus the population in 1970 divided by the number of years between it. There's 10 years. So let's substitute the values in here. The 226.54 minus 203.30 divided by 10, and don't forget the parentheses. It leaves us with 2.324 million people per year. This is a rate. So in order to find the population in 1972, let's write it out in words first. You need to find a population in 1970 plus the amount of 2-year growth. That's equal to the population in 1970 plus 2 times the average rate of change. Now let's substitute the values here. So 203.3 plus 2 times the average rate of change of 2.324 tells us that in of 1972, the estimated value of the population is 207.95 million people. This is just an estimate. This is one technique of finding an estimate. Now let's do the same thing for 2007. We know that 2007 is between 2000 and 2009. The difference in years is 9 years this time. So to find an average rate of change, we take the value from 2009, which is 308.75 million minus 281.42 million, and divide this time by 9 to get 3.04 million people per year. We're going to use this number to help us calculate end of 2007. And that's 7 years in 2000. So we write the population in 2000, which is 281.42 plus, this time is 7 times our average rate of change to give us 302.7 million people. Now we also know that tables are good in showing trends. In this example right here, we're going to look at the long-term behavior, or we call it limiting value. As time goes on, what's going on with our amount? Here we look at this experiment here of the yeast experiment, and over time here it's increasing. So every hour it increases by a certain amount. At first it increases rapidly, but then you notice the rate of increase slows down. That famous graph. It increases rapidly at first, but the rate of increase slows down over time. So how do we figure out N of 35? So N of 35, 35 is down here somewhere on our graph. And we see here that the rate of increase is slowing down. So it's safe to say we can kind of assume that our N of 35 will be about 665. It's not going to increase that much more because it increased rapidly at first, but then the rate of increase slows down. So our long-term behavior here, it plateaus out. So go ahead and start your web assignment on lesson. If you have questions, please email or call me. Have a great day. Thank you.